Okay, classwork 3.5. We have a last log rule to learn. This is very important. This is different from the two that we just learned. You want to remember that when you have one single base to a power, and then after it has that exponential happen, it's exponented again. This is different. Make sure you understand that this is different from when it's multiplication of two bases. When it's multiplication of two bases, then it simplifies into one base. It condenses down to one base by adding the exponents. But what is different on this one? You can tell me in chat what is different on this one. Yep, I'm multiplying the exponents. Now, I'm going to go over to the answers because I have down there what I knew I meant to say. So what I want you to notice is the exponentiation. Think of that as an operation where I have a particular base and I put an exponent on it. So I have b to the m. I am exponentiating the base b with an m. And that, hold on, backtrack, knee, focus. What I realize now that I meant to focus on was the exponentiation of the n. So you have this exponential piece, and that itself is exponentiated, and that is outside of the exponential. Multiplication is bonding the inputs, so that m times n happens before that result is plugged into b to the power. Inverse function, swap x and y. And just like before, this means that one function's input inside the function swaps with its inverse function's output outside the function. So what log rule does that create? And I want you to see multiplication by something outside the logarithm versus an exponentiation on the inside of that function. Understand that this is different from this. What I just wrote down, that's an exponentiation outside the logarithm. The exponentiation of this p is inside the logarithm, and it's only for what was previously in the logarithm. When you expand, you're going to go from this to this. When you condense, you're going to go from a multiplication and turn it into an exponent. Also understand that a parentheses does not have to be here. If you see right after your base in a subscript, if you see that right as you come back up to the level of log and you write something and then a power on that, it is understood that that is actually occurring all inside that logarithm. But they usually don't tell you that. So you've got to know that that's what they mean when you see it written that way. Now let's do some examples. We're going to expand. We now have 3 rules we're going to use to expand. I want you to look at number 1, and I want you to see that the 5 exponent is only on the a. It is not on the 3, and that's very important. That means that I need to see a multiplication of a 3 and an a to the 5th power, and that is inside my logarithm. So that multiplication inside the logarithm becomes addition between 2 logarithms with the same base, separating the multiplication to have a 3 separate from an a to the 5th power. With our new log rule, we can expand this logarithm further. I can take this exponent, and I am actually taming an exponent. I'm taking something that is an exponent and turning it into multiplication. I see that as taming it. Logarithms have to tame the exponentials. They have to bring things back to a y equals x balance. So the 5 is multiplying to the log base 8 that now has only a inside and no changes on the other one. And that's expanded. For number 2, what I would recommend you do is first see the big giant division bar, because there is an understood parentheses with the numerator and the denominator. So my weakest operation inside that logarithm is actually that division bar. And so I can separate the division bar by subtracting 2 logarithms. And I'm putting parentheses for emphasis. Now look at the x squared minus 25. Do you feel the need to factor that? I'm not going to throw this on a quiz or a test, because I wouldn't expect you to just look at that and realize, oh, I can factor that and I can expand further. I don't expect you to see that.
Oh, question?
Yes.
For subtraction in general, if I was to say log 5 of x, or just log 5 of x minus log 5, or log 5 of negative 25 minus log 5 of like 15, like what would that look like? If you're subtracting through logarithms from one another, is it three lines of division, like one divided by the other?
Okay, hold on. I need you to say again what you were thinking. You said if you have log.
Here, let me read you off an example, because here's on the homework, but it wasn't on the classwork yesterday. Where was it?
Oh, yesterday's classwork.
No, yesterday's homework.
Yesterday's homework. Okay.
Yeah, because it was just condensing.
Uh-huh. Which...
It was question number 6 for homework 3.
That is actually really, really valuable to take a look at. One way you can see this is you can do subtraction parentheses, and then everybody that is subtracting can go in here. but now it's addition because I'm factoring out the negative. In order to work with this, though, I have to deal with the 1/2 that's adding that isn't in a logarithm. And if you look at the base that is being used, 36, you can rewrite any number as log with a base of choice, use that same number as an input, but the exponent needs to match. Because then the 1/2 is going into, it's an exponentiation of a 36, but then the reverse process of log base 36ing it takes place immediately after, and so they actually undo each other to be just the exponent. So after this minus sign, I actually have log base 36 of t plus log base 36 of the square root of 36, which is 6, and then plus log base 36 of p, and I can then take everybody that's after this subtraction sign, it's all addition, and I can condense that into one logarithm. And I'm multiplying the t, the 6, and the p to have 6 TPs. I think I was having fun with TP because it's toilet paper. And still, I've got to say again, I had no idea how important toilet paper was about to become. But anyway, that condensed logarithm is subtracting from log base 36 of q. And now I can use the rule of when two logs are subtracting, they condense into a division where it's whoever leads the subtraction is the numerator, and whoever is after the subtraction becomes the denominators and sides. And then that would be condensed. So you can also notice that every subtraction causes the denominator. We had to do a little extra work with the 1/2. So let me point out that that 1/2 changed into log base 36 of 6. But what you're seeing is the logarithm's input of all the logarithms that are subtracting became factors in the denominator. And that's a really good one to take a look at. Thank you. I'm sure a lot of people are appreciating going over that. With this one, I want to say again, I don't expect you to see that you can do more. I really don't. Homework and classwork are different from a test. On a test or a quiz, I wouldn't give you this. X plus 5 times x minus 5 is the factoring of that quadratic. And I'm overdoing the parentheses just to make sure to keep the clarification. You can choose to use the parentheses or not use them. Now what you want to see is you have a multiplication inside a logarithm, but over here you have an exponentiation inside a logarithm. And so each of those is a different rule. And I am in my 10-minute reminder. So as I expand, this is log base 5 of x plus 5. Multiplication expands to a sum of two separate logarithms. And then for this last logarithm, I use the new rule, and that exponent 2 is now going to be outside multiplying to the logarithm. You don't need the multiplication dot, but I'm putting it there to make sure you're clear that that is the operation there. This cannot be expanded further. The temptation people have is they see the addition subtraction inside the logarithms and feel like they need to do something with that. It's very important that you mindfully recognize that inside a logarithm, addition subtraction cannot be separated. That is a tight, tight bond that you cannot separate into two separate logarithms. And then number 3. For number 3, I'm going to start with the division. So I have the log of the numerator minus the log of the denominator. And this is an understood multiplication, so I'm going to emphasize it. Then I'm looking for the multiplication that I notice inside these logarithms. And I can separate the multiplication through addition. And I need to be careful with my subtraction because I'm actually having a big parentheses with expanding based on this addition, or based on this multiplication. So the multiplication inside the logarithm causes this to be able to split into 2 logs that are being added. And these are understood base 10, and that's q to the 5th, and the square root of r are now separated. And I actually have a little bit more I can do. Do you recognize the number? If a base is not written, the base is understood to be what number? And so 1,000 is 10 to what power? So this will simplify into the number 3. Then I have log t minus, and now you need to notice that you have an exponent, and it is understood that that exponent is inside the logarithm. I can now turn that exponent of 5 into a multiplication to the logarithm that now has only what that 5 was to the power of. Additionally, what is the exponent on r when I have a square root? What is the other way to write the square root of r? R to the power of?
1/2.
You got it. So if this is r to the 1/2 power, then this exponent 1/2 can become multiplication outside the logarithm. And at that point, this is expanded. The thing I don't particularly like about expanding is it's sometimes hard to recognize whether you've expanded enough. And what you're looking for is go into each logarithm inside. logarithm inside, logarithm inside, a logarithm inside. And you're making sure that you don't have any multiplication of two things, any division of two things, or any exponent that is on everything inside that logarithm. If you don't have those, then this is expanded. There are expressions that it can get trickier, but right now I'm keeping you at a certain level of what you're working with. You're trying to get familiar with logarithms right now. Now, I'm out of time if I'm going to give you a quiz, and I intended to go through condensing, so I'm going to make another video for condensing. And on that video, I'm going to talk about the graph of cube root x. You need to make sure you watch the video, or you can also look at the answers to the classwork. If the answers make sense and you understand that this is what the cube root of x looks like, based on understanding that it is the inverse of the blue you see here, the x cubed that we learned about. So if I'm going to reflect that over y equals x, instead of reaching for the sky, I'm reaching for the sides, basically. So I am going to make another video. Make sure that you watch that video. And then I'm going to open your quiz. Can someone tell me how to unhide the things that I hid? Do you know how to unhide? Actually, I know how I can at least do this. I can tell this